session. So this workshop is part of the IBM Developer Series, where we talk security on Tuesdays, data science and AI on Wednesdays, and cloud native and Red Hat OpenShift on Thursdays. So today, because it's Wednesday, so we'll be discussing an AI topic, which is how we can build and compare machine learning models the easy way with IBM SPSS Modeler. My name is Khalil Faraj. I'm a developer advocate based in UAE, Dubai. And with us, we have my colleague, Fawaz Siddiqui, who will be facilitating this workshop, and we'll be answering your question. Anything that you have, you can simply just ask him on the chat. So to get started, first of all, please make sure to register for your IBM Cloud account. So it's on the first link. Fawaz will be sharing these links on the chat as well. And we have our asset link, which is our repository that has all the resources and the links that we're using for today's session. So for the registration part, if you simply go to the GitHub repository, you will see how you can create your IBM Cloud account. So you can simply just click here to register. It will direct to the same link that Fawaz has already shared. And there are simply just 3 steps to create your account. So the first one is just to put your email and password, and then you will get a verification link to verify your account, and then you'll just fill the personal information, like just write your personal name and your location. So this is how it looks, and we can go check it out together. So this is how you can sign up. You will just put your email, password, click next, verify your email, and then just fill your personal information and go ahead, click on create. So this is what we need so far. We will cover the rest of the information later on in the session. Let's go back to our presentation. And this is our survey link. So at any time, in case you wanted to drop out of the session, just feel free to fill this survey. It's very important for us. It just has 3 questions, so it won't take a lot of your time. And we want to give you a brief introduction on how to use Crowdcast. So basically on Crowdcast, you will be able to just say whatever you want here on the chat text field right there. You can ask a question if you want. This is the Q&A section. And basically here you can see the presentation and my screen basically. And there's the Get Started Here button. So this is the action button that has the link for our repository. So again, Fawaz has already shared it, but if you click on this button, you will be directed to the same GitHub repo. Please make sure as well to follow us right here by clicking the follow button. So let's get started. Today's agenda, first of all, we're going to start by discussing AI and machine learning, to give a brief explanation about them. And then we move and tackle the machine learning process. And then from there, we're going to talk about the different types of algorithms that we have in machine learning. And then we're going to talk about the main challenges that we are facing these days. And from there, we're going to jump to SPSS Modeler, how it can be used as a solution for all these challenges that we're facing. So what is exactly SPSS, why to use it, and we're going to talk about the main concept that SPSS rely on, which are nodes. And finally, we're going to dive into our hands-on and do the workshop part. And before starting, guys, I just want to talk about Call for Code. So this is a hackathon where we ask for developers to join and to develop solutions that can serve our community. So each time IBM focuses on a specific theme, and this year we're focusing on more of an environmental climate theme. And there is a grant prize of $200,000. And you will have the chance to meet up with some investors, some other technical people that you can collaborate with. So I think it's a very great chance to put your skill into use. So feel free to check it out. We'll talk more about this at the end, and we'll share the required link to register for it. Now, the first thing, AI, machine learning, and deep learning. I'm sure all of us have heard these 3 terms, and they are buzzy, and we can hear them all the time, and they are trending. And a lot of people confuse between these 3. So I just want to make a very brief explanation about these to make it simple. Basically, AI is just the making of intelligent systems and machines that have the power to mimic and copy human behaviors. Machine learning is a subset of AI that uses math and statistics, and it will enable these machines to improve the experience. So AI, to be able to copy and mimic human behaviors, it needs this special thing, which is machine learning in this case. Now, deep learning is not in today's context session, but I just wanted to put it there to show you how it relates to machine learning and AI. And basically, it's a subset of machine learning by itself, and it enables computers to solve much more complex problems. And of course, we see deep learning these days in all kind of different industries. So I think the best way to explain this is to have, for example, a rocket ship. And this rocket ship's goal is to go to the moon, to space. And the rocket ship in this case represents the AI system by itself. And to go to this space, it needs an engine. So the engine that's going to empower this rocket ship will be the machine learning in this case. And of course, the engine needs fuel, which is our data. So we're going to feed data to our machine learning model so it can empower our AI system. So let's talk more about the machine learning process. Now, in machine learning, we have four main phases in the process of machine learning. The first one is to define the problem and the solution, and then we need to develop and prototype our model. And then from there, we go to the production phase, and eventually we're going to measure the model. So the first part, I think it's the most important one, which is defining the problem and solution, because here we cannot just build a model without trying to know what we're trying to solve. So we need to make sure that we understand our problem, and we need to have a clear vision about our business use case. So that's why we need to understand our business needs and make sure to define a scope and to define our minimum viable product. Once this is set and is defined, then we can go to the prototype phase. And here we're going to start with our data. And this maybe can be the most complicated part, because we need to make sure that we have a good quality of data. So a data that fits our use case, the problem that we're trying to solve. And a lot of time we can see a lot of different sets, but they can have their value that they have can be a bit biased or a bit extreme. So we need to make sure that we can find a balanced data set, or as much as we can a balanced data set. So once we have our data, then we're going to prepare it. And this is where we focus more on checking the values, clean some of them, converting some of them in case we need. And once the data is set, we can start training our model. And from there, eventually, once the model is trained, we can start doing some evaluation. And once this is good to go, we can move to the next step, which is the production phase. And here we'll just production the model and deploy it. And we can start making prediction. And finally, we will go to the measurement, where we can start to measure these predictions and do some bunch of predictions and gather and analyze insights. And of course, all of this is an endless life cycle, infinite kind of loop, because there is no such thing as having a one model that's good and set to go. We always need to keep sure that we are maintaining this model. A lot of times we'll have a new batch of data that we'll need to add on our current data set that we have. So this time we need to change some of the algorithms, to make maybe a new prototype, to keep on measuring, to make sure that we have this prediction that we want, this great accuracy for a prediction that we want. So that's why we always need to make sure that we are updating and maintaining the model. Now, in machine learning, we have three main types. So the first one is supervised learning, and we have the unsupervised learning and reinforcement learning. The supervised is the most basic one, and this is basically where we kind of are feeding, the data that we are feeding to our algorithm is being labeled. So let's say, for example, we want to build a model that can classify or separate between images and between dogs and cats. So in this case, when we want to feed our data, let's say we have images of dogs. Whenever we want to feed this data to the algorithm, we're going to tell it that this image has a dog. So this is a dog, which represents a dog. We'll do the same thing with the cat. So we'll tell them that this image is a cat. So now the algorithm is understanding how a dog looks like and how a cat looks like, because we are labeling it. So with that, it will start to understand, to be able to compare them and to classify them correctly. And this is what we mean by supervised. So feeding data that's labeled by us. And the most algorithms that are used with supervised are classification and regression, and they can cover a lot of use cases from fraud detection, image classification, customer retention, and many, many more. Now, the other, as we can see here in our graph, so let's say, for example, the green dots are our cats and the blue dots are our dogs. So this is how it mathematically looks. It's just by kind of splitting them into two different sections where it's classifying them and separating them. And this is the main algorithm that we'll be using as well in our workshop. Now, the other type is the unsupervised learning. And here what we're trying to do is to build a model where the data is not being labeled. So we're feeding this data to our model, but the model doesn't know what this exact data is. So instead, the model will try to find some patterns and some relationship that we have inside our data set. Another very basic example is, let's say, I watch a lot of movies, and on weekend I usually watch horror movies, and on the weekdays I usually watch some comedy movies, right? So in this case, in my data set, the algorithm will be able to see this pattern. So it will see that this person watch horror movies. So let's recommend him, if you want to build a recommendation system. So let's recommend him a horror movie during the weekend because he's watching these horror movies on the weekend. And let's recommend him a comedy movie during the weekdays. So because of this pattern, the algorithm is understanding what I watch during what times, and it'll start recommending this kind of stuff based on this pattern. So that's why we see unsupervised learning. One of the main examples in unsupervised learning is recommendation systems. It's used with the clustering algorithm. Another algorithm is dimension reduction that's used mainly for big data visualization, meaningful compression, and others as well. Now, the last type of machine learning is the reinforcement learning. And this basically is used for gaming and robotics, mainly focusing on these kind of fields. And the thing is, with reinforcement learning, there are three main elements. We have the agent, we have the environment, and we have the actions. So let's take an example of a robot, which in this case will be our agent. And this robot is placed in a room, and this room is our environment. And you want this robot to move backward, for example. So this is the action that it needs to do. With reinforcement learning, we train our model by rewarding him points or deducting some points based on what he's doing, if he's doing the right thing or the wrong thing. So in our case, we want this robot inside this room to move backward. But let's say he moved to the left instead of moving backward. So we did a wrong move here. So in this case, we're going to deduct points from it. While if the next time, so in this case, he will understand that this is a bad thing. I shouldn't be doing this because I just lost some points. So he's not going to do this move again. And the second time we run this the robot, let's say this time he moved backward. So he did the right move because this is what we were asking him to do. So in this case, he will win some points. So now the robot understands that by going backward, he did the right thing, so he gains some points. It's kind of his rewards. So now he understands that he needs to move backwards and he shouldn't be moving to the left. So this is what we mean by reinforcement learning. So by training our agent by using a reward system. So we have a lot of challenges these days. The first one is we kind of have a very high demand for data scientists and for machine learning engineers. But the thing is that we lack of skills to meet this huge demand. And even if we do have some skilled people, but if the traditional ML techniques are very time consuming and they require a lot of effort. And what I mean by traditional machine learning techniques is basically four main elements. So the first one is the data preparation. When we want to get our data and to prepare it, this can be very time consuming. So we don't want to spend our entire time just trying to clean this data and find some missing values and do the right conversions, because this can take a lot of time, especially with the huge data sets. And then after that, we will need to go ahead and try different algorithms to see which one is the best. So we'll spend some time on deciding the right algorithm. And even if we do have all these ready, but we have another big problem, which is the deployment challenges and the strict resources. Because if we're working with a huge data set, we need to have a very powerful machine that can process all of these huge data sets with amazing GPUs that can process this amount of info. So with that, not everyone has access to these powerful machines, right? And this can cause us a lot of problem with the deployment part. So these are kind of the main four elements that we talk about when we're talking about traditional machine learning. So what we can do in this case, there are different solutions. And one of these solutions is IBM SPSS Modeler. Now, first of all, SPSS Modeler is not SPSS statistics. A lot of people think that these are the same, but the statistics one is more for targeted people. It's more for skilled and people that have programming and the technical background, and they even have they entered the research field. While the SPSS Modeler, on the other hand, is for everyone. So you can come from a technical background and from a technical background. Anyone can use the SPSS Modeler. So it's open to anyone. And basically, it's a data science and a machine learning solution, and as well as a data mining and a text analytics software application. So mainly we use the SPSS model to build our predictive models. Now, why we usually go with SPSS model? Basically because, as I said before, we don't need to have a technical background, so no programming is required. And all of these tedious tasks that we can find inside the traditional machine learning techniques here will be done by the SPSS modeler. So it kind of automates these tedious tasks that are very time consuming. It's very easy. It has a very easy interface to use, so we can simply just drag and drop the nodes, which we'll talk about later. And with that, we can simply just build a flow to test, deploy, and evaluate our machine learning model. So the main thing here with SPSS Modeler is that it can deliver the exact result that you want, and it can boost the productivity. Now, as I said before, there is this concept of nodes that SPSS Modeler rely on. We will see now in a bit, but there are 8 main nodes that we can use to build our flow. So the first one is the import node, where basically this represents our data source. So it can be a data asset, a user input, or simulated data. Now, the other thing is record operation. So in here, we can basically perform some operations on the data records, like merging and aggregation and many, many more. Then we have the failed operations. And basically, this is where we perform operations on not the data records, but on the data fields. So this is more focusing about filtering and managing the values. Then we have the modeling, which I think is the most important node, because this node is the node that will build our machine learning algorithm. And there are some additional stuff like text analytics, where we can perform text finding operation in case we want to, or graph if we want to perform sort of data visualization with chart builders, output as well, where we can show and model our results. And finally, we have the export, and we can simply just export our results so they can be viewed in third-party or any external apps. So this is kind of a brief idea about SPSS Modeler. Now we're going to talk more about it in our workshop session. So again, we want you to register so we can do the workshop with us. These links have already been shared the first time, and basically you can go here to sign up and sign in for your account. And we will be using this GitHub repository, which has already been shared, to go ahead and do the hands-on part. So basically the hands-on will consist about a banking industry use case. So, in banking, a very common use case is the loan use case. So a lot of people try to apply for a loan, and the bank wants to see if these people can actually pay back that loan, if they have enough resources to pay it back or not, because the bank don't want to accept all loans. There's a risk on that. So the thing here is we want to build this predictive model that can see if this person will be able to pay the loan back, so if the bank can accept this application, or if not, then the bank will simply decide to not move on with this applicant. So this is what we were doing. Again, no coding required. So because we were doing this with SPSS Modeler on Watson Studio, which has been rebranded to CloudPack for data. And we were basically comparing some different models and choose the best model to save it and deploy it on IBM Cloud. So please go ahead to register, and I will show you something as well. So if you go to our GitHub repository, you will see that in the assets here, we have our hands-on tutorials. So basically, if you click on this will direct you to our tutorial that we'll be doing for this session. So you can anytime later on just check it at your own pace if you want. All the steps are clearly described step by step, everything. So it's a lot of information for you. So let me go to our IBM Cloud and start this hands-on part. Now, the first thing is in IBM Cloud, once you sign in, you will see this dashboard. So this is our main dashboard. This is how it looks like. Let me zoom in a bit. I hope it is visible for everyone. Okay, so the first thing is we need to create our Watson Studio instance, because this is where we are going to build our SPSS model. So we go ahead, click on Create Resource. And from there, you will need to create a Watson Studio instance. So basically just type Watson Studio, and you click on it from here, choose it. And basically here, you're going to choose the location. So usually you choose location that's closest to region. In this case, I'm just going to leave it London. And basically you can give it a name. This is a light plan, so that's free. You can go for it, and you can simply just click on create. Now I already have my own Watson Studio instance created, so that's why right now I can't create it. But this is basically what we need to do. So we go ahead and click on create. And let me go now back to my IBM Cloud. Now the other thing that we will need to create is a cloud object storage instance. And basically a cloud object storage is where we store our files that we're working on the cloud. So if we go on create resource, again, we will search this time for cloud object storage. So this is what we need, the object storage. You can click on this. And in here we go with free, and you can give it a name as well. And click on create. So as well, this is free. These are all light versions that we can use. And now this will create our cloud object storage, which we'll be needing later on to store our file, which will be done automatically by Watson Studio. So really no need to go into any of these. You can just, for now, go to IBM Cloud. So let's now go ahead and click on our Watson Studio service that we just created. So you can see this under resources. So if we go to resources, you will see services in here. So if you click on this, and we expand the services, you will see your instance, your Watson Studio instance here. So again, we click on it. And basically now you can simply just click on Get Started. So Watson Studio is a platform by itself. So that's why it will open up a new kind of platform for you, a new tool, which will look like this. So this is how Watson Studio looks like. This is the main dashboard. Now, if you are going to Watson Studio the first time, it might ask about some information like your phone number, your name. So you can just fill these and just click Next to proceed. And it might ask you to provision some of the services, but you can just skip these for now and just go to provision the Watson Studio platform by itself. And this is how it looks like. So basically on Watson Studio, what you want to do is to create a project. And you will see here, new project. So we click on this. And we can click on create an empty project. And we will give it a name. So in this case, loan case. We can give it a description if you want. It will ask you to have a cloud object storage. So that's why we created the cloud object storage earlier. So now it will automatically see it right here and assign it. Now, in case you didn't create the object storage before, that's fine. You can again create it directly from this part right there. But if you already created, you will see it right there assigned. And if you are working with other people, you can restrict on who you need to be as a collaborator or who you don't want to. So again, this is a choice, but for now, we just everything as it is. And we will click on Create. Now this might take a couple of seconds. Creating. Okay, so this is now our project. So now we are inside our project in Watson Studio. And this is basically just the overview. So right now we have nothing. It might show you this, so you can simply just skip. We don't want the tour now. I'll be doing the tour for you. So we can close this as well. So basically, what we want is the main tab here is the assets, because this is where we're going to build on this project. So we can go ahead and click on assets, and we will see that we have nothing right now. Everything is empty. So what I want you to do is, if you go back, one second, if we go back to our GitHub repository, just clone this repo because we need some of the resources there, which is mainly this file. So this is our data file that we will be working with, create_risk_data. So just make sure to download this repository, and once it's downloaded, we will go back to our Watson Studio. And here, what we want to do is to upload this data set inside our project, right? So we can click on Browse. And in here, I have my file downloaded. I'll just click on Open. Now we're going to talk about the file in a bit and see some of the informations, columns that we want to work with. But just for now, upload it. Okay, so it will show you upload successful. And you will see now that you have an asset, which is this data file. Now we have our data asset that we can work with, but we need the SPSS Modeler flow, right? So again, this time we're going to click on Add to Project, this blue button right here, and we will go with Modeler flow. So it's this one. So this is basically the SPSS Modeler flow. We will simply just click on it. And we're going to give it a name. So let's say SPSS Modeler. Feel free to give it a description if you want. And then we hit create. So now it's going to create the model flow for us. And this will take some time, I think around a minute. So meanwhile, we can go ahead and talk about the data set a bit. Let me just open it. Okay, credit risk data. Okay, no thanks. All right, so this is how our data looks like. So the main fields we're working with are the checking status, duration, credit history, the purpose, so why this person wants a loan, his current credit amount, his saving status, if he's employed. We have all of different fields. We're not going to cover all of them because there's a lot, but basically these are some a sample of what we kind of use when working with loan use cases. So in this case, we have as well housing. So if it's rent or own for free, the job, all of these. But the most important column is this one, which is class. So the class one is basically defines if this applicant. So basically every row here represents a person, and this class represents if this person is good or bad. And by good or bad, we mean if he's good to give him a loan application, if we will give him a loan. Bad means that we shouldn't be giving him a loan because most probably he won't be able to pay it back. So basically, this is the most important column because when we want to build our model, our machine learning model, we'll be using this column as a target. So we want to build our model based on this target specifically, right? Because this is what we want to predict if a person has some resources to pay back the loan or he hasn't. And the thing is, what will happen is we'll be using all of these fields as factors or predictors for this target, right? And we'll see this later on, but this is basically what we want to do. So again, this data set is not perfect. There are some, you might see some missing values or some extreme values or some outliers. So basically outliers are some values that do not fit in this overall data set. But we want it like this because we want to see how we can fix this with the SPSS modeler. So we will go back now to our Watson Studio, made it our SPSS modeler. So now it's already there. We can start adding our data to this flow. And what we mean by that is basically to have a data node. So again, as I was talking earlier in the presentation, the most important part here in this flow is our source, which will contain our data. So in this case, this data asset. So we can go ahead and drag the data asset and drop it right here. And this is now our data asset. But we need to give it our data, right? So we can double click on this. And in here, we can click on data asset. So we will see our data file that we uploaded inside this project. So the thing is here, SPSS Modeler automatically can recognize the file that have already been uploaded to this project, just like we can see right there. We want this data set, so we'll just click on it and click select. So we can basically, we're not going to touch it, we can leave them just as they are, and we click on save. So now here we have our data node, so which contains our data source, which is the data file that we have. Of course, there are some other way where we can work with data. Basically, if we want, we can have a user input, or we can have a simulation, an extension import, but mainly we're going to work with the data asset because we already have our data set file, sorry. So now our data is here, and we can go ahead and check on. So I want to show you some of those. These are the main nodes that we have in SPSS Modeler. So these were the ones that I was talking about in the presentation. Now, for example, we can go to output and we can click on data audit. So we'll drag and drop this, and basically this is just a way to show this data what it has. So now if we click on this in here, we'll see this arrow. We can simply just drag it from here to here, and we can create this connection. So now here it will show us that there's 21 fields. So it automatically it processed this data, and it shows that there's 21 columns. So that's why we see 21. And if we run this, we can click on run. We will see more about this data. So basically, data audit is a way to get some information about the data set, like the mean, the standard deviation, this kind of stuff. So if we click on open, we will see right now every information about each column that we have, about every field. Now, of course, for the field that have a measurement of categorical, sorry. So these are strings. So that's why we will not see a minimum and maximum value, mean, or standard deviation. But these mainly will be good for any continuous values, like when we have numbers. So as we can see here, the mean and standard deviation are not between 0 and 1. So the data is not normalized, and it's much more better to have a normalized data set. So this is what we're going to do next. We're going to see how we can normalize this data to have a mean and standard deviation that go between 0 and 1. using SPSS Modeler. So this is just a way to see all of the main information regarding every field that we have. So basically, this is what a data audit node does. So now we want to fix this data set that we have. But before doing this, when we're trying to build a machine learning model, we need to make sure that we divide our data into two main sections. A section that will be split for training the model, and a section will be used to test the model. Okay, so we're going to go to the model, the field operations this time. We go here, we expand this, and we scroll down until we see the partition node. So basically, partition is this node that will help us to create this split in our data set. So if we drag and drop it, and we're going to make another connection from here to here. So now if you double click on this, you will see here how you want to train and to test your data, so how you want the partition to be. So in this case, you can choose whatever you want, but usually I do an 80-20 split. So basically, we're going to use 80% of this data to train the model, and the rest, which is 20%, will be used to test the model. Okay. We can leave everything else as it is, and we just click on Save. So now we have partitioned our data. We have this split, 80% will be used to train and the 20% to test. And now what we want to do is to fix this data set. So basically, this happens if we want to talk to the traditional machine learning. This is where basically we will take this data and try to see the missing values and to try to do some correction in it. So basically the data preparation phase. But here with SPSS Modeler, since this is a tedious task, they have an existing node that can do this work for us. So we will go ahead and take the auto data prep node. And basically now what will happen is we're going to simply just do a connection from the partition to the auto data prep. And this node will be responsible to fix this data set for us. It will prepare this data. Now, if we double click on it, we can see, we can change kind of the balance that we want to do. If we are focusing on balanced speed and accuracy, or want to make this data only optimized for speed or accuracy or custom analysis, we'll just go ahead with speed and accuracy. You can change some other fields. You can, do some tweaks with these fields. But for now, we'll leave everything as it is. And we're going to run this and to show you how the data will look like in a bit. So again, we're going to take another data audit. So we can simply just copy and paste this one. Or if you want, you can take another one from the output in here. This is the one. So again, we will drag this. And we will put this connection. So now, if we go ahead and run, so now the flow will start from the data source. The data then will go to the partition node, where our data will be split into two different sections. And then from there, it will go to the auto data preparation, where it's going to clean this data, prepare it, and fix it. And eventually, it will go to the data. So that's the one that you want. So basically, this part here, this is where you can view the output. So this is kind of track the history of what we're doing. So the first time we run the data audit, this one. And now we're running the second one, which is here. So if you can see now, there's 22 fields instead of 21. And that's basically because when we partition this data, a new column has been added, which is called the partition. Basically, this shows us which row was used to train the model and which row was used to test the model, right? Because we did this 80-20% split. So that's why we have a new field added, but it won't affect us for the model. That's fine. We can leave it as it is. And you will see that all the fields now have been named, have a different name. So they have their original name plus the word transform. And that's because this data set was, we run this through the auto data preparation. So when it's prepared these fields, it will add a new word, which is transform. So that's why now we have transform in all these different fields. But the other thing here is that now we have the data is normalized. We can see now the mean and standard deviation are between 0 and 1 for the standard deviation. So this shows that now the data is kind of normalized. So now we can close this. Now we have fixed our data set. We have this change. So basically, SPSS did it for us, which kind of fixed any missing values, focused on the outliers and the extreme values to remove them to be able to have this normalized data set. So now the next step is basically to start modeling, because now our data is ready. So again, when we're talking about the machine learning live process, We already have our use case defined. We were working with the data preparation. We prepared it. So now it's time to model this data. So we can go ahead. So in the modeling, basically, we have different algorithms that we can use. Now, in this case, I'm going to check how this data set work with the, let's say, the Lsvm. So this is basically the linear support vector machine. It's one of the main algorithms that are used for classification. Now, we can drag and drop this, and we'll do a connection from the Audit data prep to this one. So here the thing is, this is the main flow, okay? All the auditing nodes that are being added, or the output nodes, they do not belong to the main flow, the main kind of path, because these are just a way if you want to debug or just want to see the results. But this will be the main flow. So we'll go from here to here, from partition to data prep, then to our algorithm. Now you will see here that there is the word node, this sentence here, no targets. And again, when we're building a machine learning model, we need to make sure that we have a target that we're predicting for something specific. And in our case, so here, just double click on this. In our case, what we want to predict is the class field. Remember, the one that has the values good or bad, to be able to see if this person can pay the loan back, or he's a bad applicant, he cannot pay the loan back. So we're going to click on use custom field rules. And here we're going to choose our target, which again is class. So here, basically, we will see all the fields that we have in the data set after they have been transformed in the data prep. And this is the one that you focus on, the class. So and for inputs, we're going to click on add columns. And inputs basically are the predictors that you want to use for this prediction. So in this case, we're going to use everything. So we want to predict the target, which is class, using all of these different fields, right? But in this case, we're going to remove partition because it won't affect it won't add any impact on this thing. So it's useless to have it. So just remove it. And we'll click on OK. So now we have our fields. We have our target that we want to predict, which is a class. We can as well choose here if you want to modify these, but no need for that. We can just leave it as they are. And we click on save. So now the other thing is, now let me just zoom into this, like that, all right? We're going to click run. Now, again, we're doing the execution again, starting from the node to the splitting to the preparing data. So every time it's going to run this from the start. But now this time, because we have an algorithm, which is the Lsvm, the flow will generate for us a model that is using this algorithm. So once this model is generated, we will be able to get some information about this model, some metrics, its accuracy. We'll go a bit and talk about these. What we'll do next is basically we'll take some other models and to compare, we'll work with three models. So we'll be comparing these three models to check which one is the best for the specific use case. So now we're just waiting for this flow to run. It shouldn't take that much time. I think it will be around a minute, even less than a minute. Okay, so now the model is generated. I'm not sure about this warning message. This is new to me. Stream optimized failed and switching off. I think maybe because I'm using a light account. I'll double check on this later on. But for now, this is our model. So the model has been generated. We can double click, right click, sorry, to view the model. And basically, this is our model accuracy so far. So this model has an accuracy of 0.79. Okay, and we can see some more information about this measurement. So like weighted true positive rate, false positive rate, precision, the weighted precision, the recall, the F1 measure. Another thing is the confusion metrics. So we can see the percent correctness. And see the false and the true values. So this just shows the less correct and the more correct. But I think one of the most important things here is the feature importance. So basically, this field here, this part shows us the most important inputs. So these are our fields that have an impact in this prediction. So in this case, the field checking status has the highest impact for this prediction model. So it has value of 0.18. Second one is credit history. Then we have the duration transform. So these are kind of like the top 3 fields that are playing a key role. Okay, one second. Yeah. So these are the most important. So this is like our first model, right? It has an accuracy of 0.79. Now let's go ahead and do the same process, but with another algorithm. So this time maybe we can go ahead with KNN. So I'm going to drop a KNN, which is another famous algorithm, known as K nearest neighbor. And in this case, we'll do the same thing. We'll just click on this, we'll link it. And again, we will see the no target field because we need to define our target. So we double click. And then here we are going to click on fields. Sorry, so first, yeah, where's fields here? Again, we choose just custom field rules. We go to target. We will choose our target, which is the class, to see if this is a good applicant or a bad applicant. And then we click on add columns. We do this exact same thing. So we will select everything. We can remove partition, and we will click on OK. So with that, we can simply go ahead. And of course, there are some other things that you can configure. So another thing here, because every model has its own characteristic. For example, with the KNN, we can modify the number of neighbors that you want. So we can modify that. We can modify this in here, but we're not going to touch these. We're going to leave them as they are, and we can click on save. And we're going to add one last model. Let's go ahead, for example, and take random trees. So we take this, and we create another connection. We go ahead on targets. And again, we do the exact same thing. Our target is class transformed. We add the columns. We choose everything. We remove partition. We click OK. Click on save. We double check it's saved. Everything. Yeah, it's saved. All right. Okay, so now we're going to run both of these models. So let's go ahead with the first one, KNN. We right click on it, we click on run. So now again, we're going to restart the flow from the beginning. And just like we did with the Lsvm model, we're going to do the same thing, but this time with KNN. So run was successful. This time I didn't see the first error, so that's good. The first warning message. And now we have our model generated here. And then we're going to run this just like we did with the first one. And eventually this will generate for us 3 different models. And once this is done, we will compare these 3. Now, of course, usually when we want to compare models, we're going to focus on the accuracy. This is like one of the main things that we look for. So that's what we'll be doing. We'll focus on which one has the highest accuracy. And okay, I think, yeah, it's being restarted, not sure why. So yeah, we're going to work with the best model that we have. All right, so in this case now, as well, we have the random has generated its own model. So let's go ahead and click on this. Right click, view model. So just like we did with the Lsvm, we will do the same thing here. We can check the information about this model, check the metrics. Now in this case, this model has an accuracy of 0.72. So this is less performing than the first one, because the first one was about 0.79, right? Now let's check the decision trees. We are going to view the model here as well. Now this one, okay, so this is the least performant. It has a value of 0.69. So we're going to remove that. Of course, we're not going to work with that because it's the weakest. So this one was 0.72, and just to double check, this one was 79. So this has the highest accuracy. So we're going to go ahead and work with that. Now I want to try one thing as well to show it to you. Basically, we can use another kind of an output node, which is the analysis. So if you can drag and drop this here, and we can create, for example, a connection. So analysis basically is a way to show you how many predictions were done correctly and how many predictions were done were false. Basically, were wrong. So let's try to run this. Okay, so now we will see here our analysis node for the Lsvm model. In this case, this will so this will show us a table. So it will tell us first how many values we used for the training and the values we used for how many values we used for the testing, and we can see the value of the correct values and of wrong. So the total, you can see the total number. So the percentage is it has a correctness percentage of 74, and while the rest is wrong. So 25% are wrong, 74% are correct out of these predictions that the model has done. So just another way to kind of evaluate our model. Of course, there are many different things that we can do, but just simply these are just the most basic and common ways. So now we have our winner, which is the Lsvm. We're going to deploy this model. Okay, so what we will do is we're going to click on right click when we go to save model SPMML. So here you will see you just leave this individual algorithm, the model applier node. You can just leave the class transform, model name. You can give it whatever name you want. I'll just leave it as class transform. We can go ahead and click on save. So now the model has been successfully saved, and now it's added to our assets in the project. So if you close this, we go back to our project in here. We will see our assets. So again, our assets, the first thing we had was the data set. The second thing was the SPSS Modeler flow that we just built. So this is our first model data. Then we worked on the flow. And when we're working with the flow, we saw our model we want to deploy, which was the Lsvm. And we can see it right here under model. So now the model is saved in assets under models, under Watson machine learning models. So now we want to deploy this model. And the way we deploy on Watson Studio or IBM Cloud Pack for Data, basically we click on these three dots in here and we click on promote. And basically to promote, you will need to create a new deployment space. So we go ahead and click on a deployment space. And the deployment space is basically the space that has all of the different models. And the way it works is by giving it a machine learning instance. So we'll see now how. I'll just give this a name. No, my deployment space. Okay. The tag, it will of course it will need a cloud object storage. So we're going to use the one that we already created, and we need to have a machine learning service instance as well. So if you already have one, if you are already an existing user, you will see your machine learning service automatically appeared here. But if you don't have one, we're going to click on create. And this will open the catalog for us, and it will give us the machine learning service. We'll just choose location. I'll leave it as it is, London. It's light. You can give it a name, just like created the first two services we earned in this session. We go and click on create. All right, so now we have created our machine learning service, and this is my machine learning service. So now it will automatically show up in here. I can simply just choose it, and I have everything. So the name is here, my cloud object storage service is here, and my machine learning service is here. So we can go ahead and click on create. So now we're creating our deployment space. And now the next step will be is to go to this deployment space and add our model into the space so we can actually deploy. And we'll see now in a couple of seconds how we will do this. Just waiting for the space to be created. Hopefully this won't take much time. Okay, so now the space is ready. We can click on close. Now to access your space, well, basically it will automatically show us new. We will see now later on how we can access from a different way. But this is our space now. This is our target space. This is our model. Actually, I'm going to change its name. Let's do it Lsvm model. Okay, and we are going to click on promote. So yeah, the other way that I want to show you is, so now the model has been successfully promoted to Lsvm. So now we can go to deployment space to check it out. So you can now directly go from here, or if you want later on to check your deployment space, you can click on the hamburger menu, click on deployments, view all spaces. And in here, you go to spaces. We're going to close the tour, and this is my space, my deployment space right here. It's already has been created. But of course, you can simply just click on the notification that just showed up a couple of seconds ago. So this is my deployment space, and I have promoted my Lsvm model to the space, so that's why now I can see it here. So now it's time to deploy this model. So what we'll do is we click on this mini rocket icon here, this deploy. We are going to go with the online. So this is basically a way that can help us run the model in real time, and to be used as we receive by web service. So this is kind of can generate API for us where we can use this model in any external apps that we're trying to build, web apps, mobile apps, whatever we want. And we will see. We'll look at these endpoints in a bit. We'll give it a name. So let's. Okay, we click on create. So now if we go to deployments, we are going to see that this model is being deployed right now. Status is in progress. So this might take a couple of seconds. Now it's deployed, so we see the screen icon. So now if we go ahead and click on this model that has been deployed into our space, we are going, let me zoom out a bit. We will see a bit of code snippets. So this is basically a way where we can use this endpoint that has been generated. So we can add this endpoint in any of our apps. We can test this with curl, or if you're running a Java app, you can simply take this code and put it right here. Okay, there's a JavaScript, there's Python, Scala. Do have all these different code snippets, and of course these will ask for your API key and this kind of stuff. So basically, the API key we can take it from our account. We'll talk this about later on. But another thing I want to show you in here is, as you can test your model in case you want to test this with any new values that you have. So right now we don't have values. We're not going to copy paste some of the data set because it's already there. But basically what you can do is you can go ahead and put all the values in here. Another way to do it is if you already have a kind of a JSON value, you can put this as JSON, and then you can click on predict, and this will show you the result if whether this applicant with the values that you just provided is a bad applicant or a good applicant. So this is basically it for the workshop part, and this is how we can deploy our model, build a model easily on SPSS Modeler in Master Studio. And as we just did, this was just with clicking stuff, so we didn't write any line of code. I'm going to do a quick summary on that. So basically, again, what we did is we first went to IBM Master Studio. We created our project. Can just let me go to my project. So we created our project, and inside our project, we imported our data set. And then from here, we added an asset, which was the SPSS Modeler flow. So again, when we click on Add to Project and we click on SPSS Modeler flow, this is where we started to build our model. So we put our data source node there. We linked it with a couple of other nodes, like the partition one, to split our data into training and testing. And then we added the auto data preparation, so it can fix our data and to normalize it. And then from there, we were able to just put some of the algorithms that we want to use for this model, and with a couple of seconds, the SPSS was generating the model for us. We compared 3 of them. We saw that the Lsvm was the best one. So we just deployed it. And to deploy the model, we need to create a deployment space, and then to just promote it there. And from there, we can simply just deploy it, just like we did right now. So this is basically how we can do how we can build models easily on an Austin Studio. Another thing I wanted to show you is I'm not sure if this is. I think it's an account. So basically, if you want to take the API key in case you want to build this into your own application, we can take the API key from here. I'm just trying to remember where exactly. I think it's from the access identity. Okay, yes, so this is it. So you go to your manage in your IBM Cloud now. So you go in manage, then you go to access IAM, and you will click on API keys. And basically here you will just click on create an IBM Cloud API key. We'll give it a name, description if you want to, click on create, and this will generate for you an API key that you can use inside the code snippets that I was showing you before. So you know these the endpoint when it was generated, we have these different code snippets in case you want to integrate our model with a web app or a mobile app that you're building. They will ask for an API key, and this is where we can get our API key from here. So again, we go to manage, IAM, API keys, create one, and we put it right there. So yeah, that's it. Let's go back to our presentation to conclude what we have done. So again, this workshop, we worked on a loan use case, a banking use case, a very common one. We wanted to see how we can build a model easily that can predict whether an applicant can apply for a loan, so the bank can accept his loan application, or if the bank should reject it. With this, without any coding, we just use SPSS Modeler in Watson Studio. We compared a couple of models, and we saved the best one on IBM Cloud. And we saw as well how we can integrate these with any mobile app or web app that we want. So that's it for the workshop part. As I said earlier in the session, there is this call for code hackathon. So I just want to add a couple of information about it in case you're interested. So again, this is a great way to build some skills, to meet some new people, if you have any ideas, to put them into action. You will join a community that has more than 400,000 developers from all different nations. So I think it's a great way to learn new stuff. And before we already talked about the awards, maybe we'll have 200,000 for the global challenge winner. Now the thing is, as I said before, IBM focuses on a theme every year, and this time we're focusing on the climate change. There are 3 main tracks. So the first one is clean water and sanitation. The second one is zero hunger, and the third one is responsible production and green consumption. So if we kind of have a solution for any of these tracks, just feel free to apply for it. And as well, we do host office hours every Monday from 2 to 3 Dubai time. So in case you have any more questions or anything about this, you can just feel free to reach out and to attend this session to ask us anything that you want. And we do provide some starter kits. So this is basically like if you want a template that you can go ahead and start from them. They are kind of sample apps that you can see how they work and build on top of these. They are open source on GitHub. You can just clone them and see how they work. And these are as well, they are shared in our current GitHub repo that I just shared with you. So all the links you have access to, you can simply just check these out. So again, if I go to my GitHub repository, if you scroll down, you will see here everything regarding call for code in case you want to participate with the starter kits. Another thing is we are hosting our digital developer conference regarding data and AI. So again, if you have more information about data and AI, the conference is on June 8th. So feel free to attend. We will talk about all kinds of different data and AI technologies that we have on IBM. So there's a great way to learn some new skills, and you'll be learning from IBM expert, and a lot of partners will be attending. Basically, the entire worldwide community will be there. So just feel free to check it out. And some useful links at the end that I want to talk about. Basically, you will see the get started here. This is just to create your IBM Cloud account in case you don't have one. The hands-on lab, and this is basically the GitHub repository that has all the links and the assets for this session. And there is the IBM Developer Portal. So this is kind of it's a website where you can learn any technology that you want. So we cover everything from blockchain to security, data and AI, microservices. So we see a lot of videos, tutorials, code patterns. If you want to learn something specific, I think this is the best way to start. You can go there and check the content that we have. And finally, you can follow us on Meetup and check our events in case you if you have any kind of any technology you want to check on or you want to know about, you'll be able to see what kind of event or how we are hosting and when we are hosting them, so you can feel free to attend. And with that, we can conclude our session. I want to thank you with that. I hope you enjoyed your time and you learned something. So these are our contact information. My email, khalil@faraj@ibm.com, and Fawaz Siddiqui, who was facilitating this workshop. He was answering any questions that you have in the chat. And please, again, make sure to fill the survey. It's very small, just 3 questions. Basically, this helps us to see how we can improve, and if you are interested, to know what kind of topics you would like to see next. So we would really appreciate it if you can just fill this very small survey. I think we are done with that. Let me check if we have any questions, or let's go check the audience. So here we're going to close this. So I'll be waiting a couple of minutes. If you guys have any questions, please feel free to ask. And again, I really suggest to attend the conference that we're having on June 8th. We will do as well more additional workshops. We'll be covering different topics. We have Auto AI, something similar to SPS Modeler. We have as well working with Watson Assistant. So everything from when it comes to data and AI. So I think it's very interesting to check it out in case you want to go. And please feel free to survey again one more time. This is very important for us. Okay, I think we don't have any questions. So if we don't have any questions anyways, I'm going to share our emails again if you want to reach out later on. So just 1 second. Go here. Copy this. Okay. So these are our contact info. Again, feel free to reach out. And I think we can conclude this session. Thank you everyone for joining. I hope you enjoyed your time.